Here's what we're going to do. There's a series of steps which are in common between all of us no matter what you measured, and then there will be some things where you go off and you'll do something separately depending on what you were looking at. Okay? So here's the common part. We all took pairs of measurements. Every time we took two measurements and they went together, okay? The first measurement was what we used the clinometer for, right? Which was this angle, okay? Like so, right? Now let me just, let's pick one example. Peter, you measured the flagpole, right? What was one of the angles? Any angle that you measured?
It was 52.
52 degrees. Okay, so my diagram's not to scale. That's clearly not 52 degrees, but that's fine. Now with that angle, you should also have measured that distance, that length, right? So how much? 9.4?
Yeah.
Okay.
Yeah, 9.4.
9.4, right.
No, it said 94, I think so.
That's alright. So here's what we're going to do with this. Okay. Wait, are you sure it wasn't like 94 inches or anything like that?
I'm not sure, it just said 94.
We'll call it 9.4 meters for now and we'll check it later. Okay? Shh. Now, you'll have some different measurements, but here's what we're going to do, right? We want to find this. How high is this thing, right? Now, I should actually be careful. See, we're standing on the ground in my diagram, right? But remember I told you that we're actually measuring from your eye point, okay? That's where the angle is coming from, okay? So later on, you're going to need to work out what your height is and add it onto this, okay? The part that we're going to get from trig is just this part, from your eye upwards, not including your height. Okay, so I'm going to call this h for height. Okay, so we'll call that one h over there. Now, what do we got here? You got an angle over there in the corner, and just like before, I want to work out now which ratio is going to be useful to me. Okay, now you have a look. I've got this side which is opposite the angle, and I've got this side which is adjacent to the angle. So I should use tan. Yeah, you can see it's that one. Okay, so tan 52 in this case, right, degrees, will equal to opposite on adjacent. H over 9.4. Okay.
So do we need the height of the object?
The height's what you're going to find out through trig, right? So for example, here's what we're going to get. I can get this 9.4 over the other side. I can multiply, so 9.4 tan 52 degrees. Okay, so you get your calculator there, and you say, well, what is 9.4 times tan 52 degrees? And you chuck it in. And you get, well, I've got this. I've got 12.031415 and so on meters. Now, does that sound like a flagpole to you?
No.
It's, well,
Roughly.
yeah, reasonably. Like if you could picture, like 12 meters is kind of like, let's see, divide 12 by like 1.7 maybe, so that's like 7 people end to end. Does that seem about right?
Yeah.
It's in the ballpark, at least, okay? And here's the important thing. You will have multiple measurements for your angle and for your length, right? Or you may have measured another object, okay? So here's what I want you to do. I want you to come up with as many of these as you can. It's like, I've taken my measurements for the height of the flagpole, and I've got this measurement, and then another one, another one, another one. Are they the same? Are they different? How different are they? You might have done a building, or a tree, or whatever, okay? So I want you to group up with the people who measured the same object as you, and work out what these numbers are, okay? Off you go. Okay, everyone, let's discuss this. Now, I'm going to get some measurements off you for two things. I'm getting these because specifically I know that we have several measurements for them that we can compare. Sometimes we had no measurements, unfortunately, but you can have a look at doing them maybe later and trying to compare. We already have one for the flagpole that apparently we got a measurement of 12 meters. What were the other ones? Can you help me out? Maybe give it to me one decimal place would be good. So this would be 12.0. What was another one? 6.0 and 12.0. Was there any other measurements that you guys got?
No.
That was it?
We
Okay.
did the basketball one, but that's, yeah.
Did other people do the flagpole? Anyone else?
Oh, we did.
Didn't you guys do the flagpole? Yeah, what did you get?
10 meters and 8 meters.
10.7,
10.725.
okay, and 8?
0.3.
8.3, okay. I'll leave that there for a second. Jacob, do you have some measurements for the building? 3 of them?
I have 3.
Yep, what do you got?
First one was 8.51 meters.
Yep.
The second one was 3.24.
3.2. Yep.
3.24.
You got 3.2 twice, did you? All right. Okay. Now let's have a look at this. From both of these sets of data, you can see something very interesting. For instance, you compare these two, right? You compare these two. There is a huge margin of error in there. Okay, now this is actually very, very important. Amy, Chloe, do you guys mind waiting outside for me? Is that okay?
Why?
Because you're disturbing the rest of us.
Okay.
I'll wait.
They're looking.
Close the door, please. Where were we?
You
said
The
height
margin
difference.
between.
Thank you. Okay, we were comparing these, and we said, oh man, these are huge differences. Clearly, something's gone wrong. Okay. Now, I think we've thought of some of the things that could go wrong. For instance, we came up with a pretty obvious one here. What was the discrepancy between
The
these?
height.
Yeah, good. So if I just do a really rough sketch of like, here's the ground leading towards the serpentine wall, and then there's some steps, and then there's like, you know, this area, right? So if you've got your flagpole, where is the flagpole? Is it here?
No, well, there's another pair of
further.
set.
A bit further up.
Yeah,
I'm just going to draw it
another pair of
there.
steps.
Okay. Now, obviously, if you're measuring from down here versus measuring from here, okay, these people are different heights. They're like different meters apart, just vertically, right? So that's where something like this can creep in. Okay. However, then you lead to problems like this. Now, these were not from clearly different heights. Okay. It was sort of. I mean, I don't think it was perfectly level, but it was reasonably level. Okay. And you had like some building over here, and I think the three measurements were what, 5 meters away?
5, 10, and 27.
10, so that's like twice as far, and then 27 is like all the way over here. Okay, now, this is a legit question. Why would the differences be so huge, right? Now, I think we'll get an answer if we have a think about what the triangles look like. Okay, so here's this one here, which is the closest one. Okay, so measuring this angle in here. I'm going to have a few, so I'm going to give them different names. Okay, I've got an alpha there, I've got beta here, and then I've got, I think I'll call that gamma. Okay, now, just think with me on this one. In particular, think about this angle. I think this one will give you the most information, right? Now, do you remember when you were doing this, right, and you were holding it and you were trying to like, do up and down, okay? How difficult did you find it to get it like completely still and get an accurate measurement? It was pretty okay, yeah? And here's the tricky thing, right? When you're back over here, okay, a tiny fluctuation in your arm makes the difference of, say, like maybe 2 degrees. Maybe 2 degrees, which doesn't sound like a lot, does it? Like, for example, if I was over here, there's hardly a difference between 70 degrees and 72. Not a big deal, okay? But if you're over here, right, and because this angle is very small, right, suppose we were far away enough that it was like 4 degrees, maybe? Well, if you're off by 2 degrees, 4 and 6 are hugely different, right? Like one's a whole 50% bigger than the other, right? Which is why some of these measurements are off by such incredible margins.
Is there like a